Join me on this episode to learn how to get started with Renesas DA14592, a low-power, multi-core Bluetooth 5.2 solution designed for applications like asset tracking, connected health, and IoT. With features like ultra-low power consumption and advanced security, this system on chip is perfect for compact, energy-efficient devices. Hi, welcome back to TechVentures. My name is Lazina, and I'm a technical marketing engineer here at Future Electronics. If you're interested in checking out any previous episodes, then please check out the description box below. Meet Renesas DA14592, a compact yet powerful Bluetooth LE chip that boasts ultra-low power consumption and an incredibly small footprint, making it perfect for everything from smart medical gadgets to asset trackers. With its multi-core processing capabilities, plenty of on-chip memory, and just 6 external components needed, this chip is a powerhouse of efficiency and versatility. Today, I'm going to show you how to get started with the evaluation board. We're going to need a couple of things. On the hardware side, we'll need the DA14592 Dev Kit Pro. And on the software side, we'll need a few things: a Windows or Linux operating system, E2 Studio, Smart Snippets Toolbox, and the Renesas SmartBond App. In the box, we have the DA14592 main board, a mini USB cable, the DA14592 daughter board. The daughter board has a switch to select the power source for the device. When the switch is in the left position, the daughter board is powered by the motherboard, which is the default. When the switch is in the right position, the daughter board can be powered by battery and can operate standalone without the motherboard. Connect the daughter board to the main board like so. Next, connect the boards through the USB 1 connector using a standard mini USB cable to your host PC. Next, let's prepare our software environment for our first demo. We'll need the E2 Studio. The latest version is available for download from the Renesas website. All Renesas BLE development boards include a Seger J-Link debugger with standard debug features like single-stepping, breakpoints, and software download. Run the installation file. Once the installer is running, a dialog box will open up with the following options. Select Custom Install, then select Next. When you get to this page for the device families, select Dialog, then select Next. When presented with these choices, select Get Integration and Terminals, and of course, select Next. There's a lot on this page, but I'm going to leave everything as is. Select Next. In the additional software page, I'm going to unselect everything and only select the box over here at this moment that's not selected. So that's the GNU ARM embedded 7.2.2107Q4. I can't believe I said all of that out loud, to be installed. And then click Next. Keep in mind, this page is not shown if you selected the Quick Install option. Accept the terms and conditions for the software agreement, select Next. Install the drivers, and then select Next again. And here we've got a summary of all the components that will be installed with the E2 Studio. If you're happy with that, select Install. Otherwise, you can always go back and deselect or add components that you need. The results page is shown when the installation process is complete. Click OK to proceed. Launch E2 Studio if it didn't already open a window. For our first demo, we will run the PXP Reporter. This application is a sample implementation of the Proximity Reporter within the Proximity profile. It includes the mandatory link loss service and also supports the optional immediate alert and transmit power services. We need to import the project into our workspace. To do that, go into File, Import, Dialog SDK, Project, select Next. You'll be greeted with a window like so. You'll be prompted to select the SDK root directory. So go ahead and select the Browse button. Go ahead and look for your DA14592 SDK folder. The folder name should look something like this. Continue clicking through. Once you get here, select Projects. And we're just going to leave it at the DK_apps. Now we have all the example projects at our disposal. Scroll down until you find the PXP_Reporter. Oh, there it is. Select that and then press Next. Next, we need to identify our target device. So select the 3 dots over here, and you'll see there's a whole list of choices for dialog devices. I'm going to expand this over here and select the DA14592. Select OK, and we are good to go. Just need to make sure we've got the correct toolchain selected. Don't forget that. And now we can press Finish. The project will open up in the Project Explorer pane. That wasn't there before, so now we can go ahead and expand the config folder. And we're looking for the PXP_Reporter_config.h file. And of course, it's under the config folder, so here we go. We're going to change the advertising name. Right now, the default name is Renesas PX Reporter. Now, this step is optional. If you'd like to personalize it, you can modify line 38 between the quotations. Don't forget to hit save. Next, we're going to build a project using the hammer icon. So mosey on over to the hammer. There's a drop-down menu. There's a lot of options. For today, we're going to need the debug eFlash option, not the one that says debug eFlash software update over the air, or also known as SWOTA. So select that, press the hammer icon, and let's wait for it to build. Yay, success, no errors. Okay, next we need to select the bug icon. Select Debug As, select the debug configurations, and then under the Renesas GDB hardware debugging, select the debug_eFlash option, and everything looks like it's okay. So we can go ahead and select debug. And with the debugger running, we've entered into the debugging perspective. This is where you could set breakpoints if you needed to. I'm going to go ahead and run my demo by pressing the play button over here. And you can observe that there's a green bar at the bottom left-hand corner of the window that says running. So this is how I know I've successfully loaded my code onto my hardware. The next part of this demo requires the use of the SmartBond app. Please go ahead and launch it on your phone, and don't forget to turn on your Bluetooth and location services. You'll be greeted with a screen like so. If you're not able to find your device advertising, please hit reset on the board. If you're using an iOS environment, you may see the old name advertising. To overcome that, delete the cache by disconnecting and starting your Bluetooth connection settings again. Once you see your DA14592 advertising, in my case, it's Lazina, select Connect. Once connected, we have several options. Under the Client tab, select Immediate Alert. That expands to show alert level. And if you press the arrow, you get more choices. So we have 3 choices. If we select the mild alert level, the LED on the daughter board blinks at a slow rate. And then if we go back and change our selection to the high alert level, the LED blinks at a fast rate. You could, of course, choose no alert if you're not into LEDs, and that's okay.
Well, that was pretty easy. That didn't even require any code modification. This wraps up the first part of our tutorial on getting started with Renesas DA14592 Pro Kit. In the next video, we'll dive into more advanced features like the Smart Snippets Toolbox and the Power Profiler, exploring how to measure and optimize power consumption for efficient device performance. Thanks for watching, and I'll see you in part 2.